At 23:45 on the 19th of October, 1942, Lieutenant Robert Lynch crouched behind the wheel of PT-48, watching 3 Japanese Daihatsu barges cut through black water off Cape Esperance. He was 26 years old, 14 night patrols, 0 confirmed kills. The barges were moving 60 troops and ammunition to reinforce Guadalcanal. Each barge carried a Type 92 heavy machine gun and quarter-inch steel plate armor. Lynch had 4 Mark 8 torpedoes mounted on PT-48. Each torpedo weighed 2,600 pounds and carried a 466-pound TNT warhead. The minimum depth setting was 10 feet. The Japanese barges drew 5 feet of water. His torpedoes would pass directly underneath them. By mid-October 1942, Motor Torpedo Boat Squadron 3 had lost 6 boats in the waters around Guadalcanal. 17 sailors had died. The pattern was simple and fatal. PT boats detected Japanese barge convoys. PT boats attempted torpedo runs. Torpedoes missed. Barges returned fire. PT boats withdrew or burned. The twin .50 caliber Browning machine guns mounted on PT-48 could fire 850 rounds per minute against wooden fishing boats, devastating. Against armored Daihatsu barges, ineffective. The rounds sparked off the steel plate and did nothing. Japanese forces were running supply missions down the slot every night. Americans called it the Tokyo Express. Destroyers and fast cruisers brought troops, ammunition, and food under darkness. When American aircraft made destroyer runs too dangerous, the Japanese switched to barges, slower, smaller, harder to detect. Immune to PT boat torpedoes, squadron commanders at Tulagi were desperate. Some crews had mounted single-shot Army M3 37mm anti-tank guns on their bows. They removed the wheels and lashed the guns to timber planks. One shot, then manual reload while Japanese machine guns raked the boat. Not sustainable. The real problem was mathematics. A Daihatsu barge could carry 60 fully armed troops, or 8 tons of supplies. The Japanese were running 20 to 30 barges per night past Guadalcanal. PT boats had to sink multiple barges per Pascal troll to disrupt supply lines. Single-shot guns could not do that. Henderson Field sat 3 miles inland from Lunga Point. Marines had captured the airfield on the 7th of August. By October, the field was a graveyard. Wrecked aircraft lined the runway apron. Japanese bombing raids hit Henderson almost daily. Betty bombers, 0 fighters. The Americans scrambled everything they could fly. P-400 Airacobras, F-4F Wildcats. Damaged aircraft crashed on landing. Some burned, some simply died. Dozens of Bell P-39 Airacobra fighters sat in pieces around Henderson Field. The Airacobra was a strange aircraft. The engine sat behind the pilot. The propeller shaft ran under the cockpit. This unusual design created space in the nose for something remarkable. A 37mm Oldsmobile M4 automatic cannon firing through the propeller hub. The M4 cannon could fire 150 rounds per minute, 30 rounds per H-horse-shoe, shaped magazine. Muzzle velocity of 2,000 feet per s-econd. The cannon was designed to destroy light armor and aircraft. High explosive rounds, armor-piercing rounds, devastating firepower. Most P-39 wrecks at Henderson were total losses. Engine seized, wings sheared off, fuselages broken. But the cannons were intact. Hydraulic recoil systems, feed mechanisms, barrel assemblies, everything needed to make them work. On the 20th of October, Lynch walked Henderson Field at dawn. He counted 23 wrecked Airacobras. Mechanics had already stripped useful parts. Instruments, radios, control cables. Nobody had touched the cannons. They were aircraft weapons. No mounting points on PT boats, no doctrine for installation, no official approval. Lynch stood next to a P-39 with its nose buried in coral. The 37mm cannon protruded from the propeller hub like a steel finger. He did the math. The M4 weighed 188 pounds without ammunition. The hydraulic recoil system added another 45 pounds. Total weight approximately 230 pounds. A PT boat's bow deck could support that. Barely, the cannon's rate of fire was 150 rounds per minute. Against a Daihatsu barge with quarter-inch armor, those high explosive rounds would punch through like paper. If the cannon could be mounted, if it could be aimed. If the deck didn't collapse from recoil forces. Lynch found Chief Machinist's mate Donald Frey in the machine shop at Tulagi. Frey was 34 years old, Navy enlisted since 1928. He had built engine mounts, repaired shafts, fabricated parts from scrap metal. Lynch explained what he needed: a mounting system for a 37mm aircraft cannon. On a PT boat bow, strong enough to handle recoil, mobile enough to aim. Frey asked 3 questions. How much does it weigh? How much does it kick? How soon do you need it? They pulled the first M4 cannon from a wrecked P-39 on the 21st of October. The extraction took 4 hours. The cannon was bolted to the aircraft's engine mount through 6 hardened steel bolts. They had to cut through aluminum framework to access the mounting points. Technical Sergeant James Coogan from Henderson Field's armament section supervised the removal. He knew the weapon specifications, its quirks, its maintenance requirements. The cannon came free at 1600 hours. They loaded it onto a truck and transported it to Tulagi. Frey cleared a workspace in the machine shop. He had a lathe, a drill press, a welding rig, and a collection of steel stock salvaged from damaged equipment. The mounting system had to solve 3 problems. First, the cannon needed a stable platform that could handle recoil forces without tearing through the PT boat's plywood deck. Second, the mount needed to rotate for aiming. Third, the entire assembly had to be installed without structural modifications that would compromise the boat's hull integrity. Frey designed a pedestal mount steel base plate, 24 inches square, quarter-inch thickness. The plate would distribute the cannon's weight and recoil across a larger deck area. A vertical steel pipe 6 inches in diameter. Schedule 80 wall thickness, welded to the center of the base plate. The pipe served as the rotation axis. A collar assembly at the top of the pipe held the cannon. Bronze bushings salvaged from aircraft wheel assemblies allowed the collar to rotate smoothly. The design was crude but calculated. Frey had considered 3 alternatives before settling on the pedestal. First option, bolt the cannon directly to the deck. Simple, but the recoil forces would concentrate on the mounting bolts. The plywood deck would crack within 10 shots. Second option, build a cradle mount similar to those used for .50 caliber machine guns. Lighter, more elegant, but insufficient structural strength for a 230-pound cannon, firing at 150 rounds per minute. Third option, weld the cannon mount to the steel bow frame beneath the deck. Strongest solution, but it required cutting through the deck and compromising hull integrity. Unacceptable. The pedestal mount spread the load. The 24-inch base plate contacted the deck across 576 square inches. At 370 pounds total weight, that meant 0.64 pounds per square inch of static load. PT-48's deck was 3/4-inch marine plywood over oak stringers. The stringers ran longitudinally beneath the deck at 18-inch spacing. The base plate would bridge across 3 stringers, distributing weight to the hull structure. Recoil forces were the real problem. Each 37mm round generated approximately 1,200 pounds of recoil force. The hydraulic recoil system on the M4 cannon absorbed most of that energy, but the mount still had to handle residual forces transmitted through the weapon. Frey calculated the mount needed to survive sustained firing at maximum rate. 30 rounds in 12 seconds meant 30 recoil impulses in rapid succession. The welds had to hold, the bolts had to hold, the deck had to hold. He over-engineered everything. The steel pipe was Schedule 80, when Schedule 40 would have been sufficient. The base plate was quarter-inch steel when 3/16 would have worked. The collar assembly used bronze bushings salvaged from aircraft landing gear, when simple steel sleeves would have rotated adequately. Frey built the mount to survive abuse because he knew it would be abused. The fabrication took 36 hours. Frey worked through 2 nights with a machinist's mate assistant. They welded the base plate structure, machined the rotating collar, fitted the bushings. The mount weighed 140 pounds, combined with the cannon's 230 pounds. Total weight was 370 pounds concentrated on PT-48's bow deck. On the 23rd of October, they installed the mount on PT-48. The base plate was bolted through the deck into the longitudinal stringers beneath. 12 half-inch bolts. Frey added a steel plate backing under the plywood to prevent crushing. The cannon was mounted in its collar. The assembly worked. The collar rotated. The cannon elevated and depressed through a 45-degree arc. Lynch's commanding officer saw the installation and called it a Junkyard special. Other PT boat commanders laughed. A salvaged aircraft gun lashed to a homemade mount. The thing would tear itself apart on the first shot or rip through the deck. Lynch test. Fired the cannon on the 24th of October in Iron Bottom Sound. Single shot. The M4 roared. Muzzle flash lit the bow deck white. Recoil drove the gun backward in its mount. The deck flexed, but held. The pedestal mount held. The bolts held. Lynch had chosen Iron Bottom Sound for the test because it was 3 miles from the nearest Japanese position. If the cannon exploded, or the mount failed catastrophically, they would be far enough from enemy observation. The test was scheduled for 1400 hours, full daylight, calm seas. No need to complicate the test with darkness or rough water. PT-48's crew watched from stations aft of the cannon. Engine room crew, radio men, helmsmen. Everyone wanted to see if the Junkyard gun would work or kill them. Lynch had cleared the bow deck except for one volunteer gunner, Seaman Mitchell. He would fire the weapon. If the mount failed and the cannon tore loose, Mitchell would die first. The first shot confirmed 3 critical factors. First, the pedestal mount could handle the recoil forces. The base plate remained flat against the deck. The bolts held. No visible cracking in the plywood. Second, the rotating collar functioned under firing stress. The bronze bushings absorbed the rotational forces without binding. Third, the M4 cannon itself operated reliably after extraction from the wrecked P-39. The hydraulic recoil system cycled correctly. The feed mechanism chambered the next round. Lynch fired a second round. Same result? Third round. Fourth, the weapon worked. The mount worked. The deck survived. After the 4th shot, Lynch inspected the installation. He checked each bolt for tension. No loosening. He examined the deck around the base plate. Minor stress marks in the plywood, but no structural damage. He rotated the collar assembly manually. Smooth movement. The bronze bushings showed no excessive wear. The crew was convinced. Mitchell climbed back onto the bow and fired 5 more rounds in rapid succession. The cannon cycled at full automatic rate. Spent casings ejected cleanly. No jams, no misfires. The mount absorbed 9 consecutive recoil impulses without degradation. Lynch declared the test successful. PT-48 now had a weapon that could destroy armored barges. Ammunition was the next problem. The M4 used 37 times 145 mm rounds. Henderson Field's Ordnance Section had horseshoe magazines for P-39 aircraft. Each magazine held 30 rounds. They loaded 6 magazines for PT-48. High explosive rounds designed to destroy aircraft. Against quarter-inch barge armor, the rounds would be devastating if they hit. At 23:45 on the 25th of October, PT-48 departed Tulagi on patrol. The mission was identical to the previous 14 patrols Lynch had run. Intercept Japanese barge traffic moving down the slot. This time he had the cannon. Radar operator Seaman First Class Mitchell sat behind the 37mm cannon on the bow. He was 22 years old. He had never fired a 37mm cannon before. Nobody on PT-48 had. Coogan had provided basic instructions at the dock point. Press trigger, change magazines, when empty. The hydraulic recoil system would absorb most of the shock, probably. The night was overcast. No moon. Visibility approximately 200 yards in ambient starlight. Sea state calm. PT-48 ran on 2 engines at 15 knots to reduce noise and wake signature. The 37mm cannon pointed forward. Mitchell sat behind it with 6 loaded magazines stacked within reach. At 23:55 hours, PT-48's radar operator detected surface contacts bearing 320 degrees at 4,000 yards. 4 contacts, speed approximately 8 knots. Lynch altered course to intercept. The contacts were consistent with Daihatsu barges running supplies down the slot. American doctrine for PT boat attacks required closing to 1,000 yards before launching torpedoes. Optimum torpedo range was 800 yards. Closer increased hit probability, but exposed the PT boat to return fire against barges. With torpedoes that could not hit them, the doctrine was worthless. Lynch needed to get close enough for Mitchell to fire the cannon effectively. At 3,000 yards, Lynch could see the barges silhouetted against darker water. 4 Type A Daihatsu barges in line formation. Each barge was 49 feet long with a 14-foot beam, powered by a single diesel engine, maximum speed 12 knots. Each barge carried a Type 92 heavy machine gun mounted amidships. The barges were transporting troops. Lynch could see the shapes of men sitting on deck. PT-48 closed 1,500 yards. Mitchell charged the 37mm cannon using the manual charging handle. The mechanism worked. The first round seated in the chamber. He flipped the safety off. The cannon was ready. Nobody knew what would happen next. At 1,000 yards, the lead Japanese barge detected PT-48. The Type 92 machine gun opened fire. 7.7mm rounds stitched the water 30 yards short of the PT boat. The tracer rounds drew orange lines across black water. Lynch maintained course. He was committed now. Mitchell opened fire at 800 yards. The 37mm cannon roared. Muzzle flash lit the entire bow deck white. Recoil drove the gun backward in its mount. The deck flexed. The pedestal mount held. The cannon fired. The sound was unlike anything on a PT boat. Deeper than the .50 caliber machine guns. Sharper than the 20mm Oerlikon. The concussion wave rolled across the deck. Empty shell casings ejected from the right side of the weapon, clattering onto the plywood deck. Each casing was 6 inches long, brass still smoking. Mitchell kept his finger on the trigger. The M4 cycled at 150 rounds per M in Ute, 2.5 rounds per S econd. The horseshoe magazine held 30 rounds. Mitchell emptied the magazine in 12 seconds. He had never fired a weapon this powerful. The Navy had trained him on .50 caliber machine guns. Steady pressure, controlled bursts, walk the tracers onto target. The 37mm cannon had no tracers. He was firing blind into darkness, aiming at a shape 800 yards away, trusting the weapon's ballistics. The high explosive rounds hit the lead barge along its waterline. Each round exploded on impact. The first 3 rounds punched through the quarter, inch steel plate like cardboard. The 4th round detonated inside the troop compartment. The barge's diesel fuel tank ignited. Orange flame erupted from the center of the barge. Men jumped into the water. Mitchell could see the results now. Each impact created a white flash against the barge's dark hull. The high explosive rounds were working exactly as designed. Against aircraft aluminum, the rounds would penetrate and fragment against quarter. Inch steel plate, the rounds penetrated and detonated with full force inside the hull. The lead barge's Type 92 machine gun went silent. The gunner was either dead or abandoned his position. The barge continued forward on momentum, but it was dying. Flames spread from the fuel tank to the wooden deck planks. Smoke poured from the troop compartment. The barge began listing to starboard. The barge was still moving forward under momentum. Mitchell changed magazines. The empty magazine clattered on the deck. He slammed the second magazine into the feed mechanism. 7 seconds to reload. The magazine change was more difficult than training suggested. In daylight practice at Tulagi, Mitchell had changed magazines in 5 seconds. Now, in darkness with adrenaline, with the deck pitching slightly from PT-48's maneuvers, the reload took longer. His hands fumbled the magazine alignment. The horseshoe shape had to orient correctly to engage the feed mechanism. He got it seated on the second attempt. He engaged the second barge at 600 yards. The range was closing fast. PT-48 was making 18 knots now. The second barge was turning to present a smaller target. Its helmsman was reacting intelligently, trying to minimize the exposed profile. Mitchell fired 30 rounds in 12 seconds. The high explosive rounds walked across the barge from bow to stern. The first rounds hit the water short. Mitchell adjusted his aim point, leading the turning target. The next burst caught the barge amidships. The Type 92 machine gun was hit directly. The gun mount exploded. The gunner disappeared in the flash. The second barge began taking water. It was not burning, but it was sinking. The bow dipped. Water poured over the forward deck. The barge's diesel engine was still running, pushing water through the compromised hull. The troops aboard were abandoning ship. Mitchell could see men jumping into the black water. Some were swimming toward shore. Others were floating motionless. The high explosive rounds had sprayed shrapnel through the troop compartment. Many were wounded before they hit the water. The third and fourth barges were scattering. One barge turned west, the other north. Lynch chose the westbound barge. PT-48 came about hard. The turn was violent. Mitchell grabbed the cannon mount to avoid being thrown from his position. The bow swung through 90 degrees in less than 10 seconds. PT-48's engines roared to full power. The boat accelerated to 25 knots. Mitchell rotated the cannon mount. The collar turned smoothly despite the boat's motion. He acquired the third barge at 700 yards. The barge was running for the coast, heading toward the darker water near Cape Esperance. If the barge reached shallow water close to shore, PT-48 could not follow. The Elko 80-foot PT boats drew 3 feet of water. The coastal shallows off Guadalcanal dropped to less than 2 feet within 100 yards of shore. Third magazine, 30 rounds. The barge was making full speed now, approximately 12 knots, running for its life. Mitchell led the target. He aimed for a point 20 yards ahead of the barge's bow, accounting for the target's movement and the round's flight time. He fired. The rounds impacted along the stern. Mitchell's lead calculation was incorrect. The barge was slower than he estimated, or his aim point was too far forward. But the stern hits were effective. The diesel engine compartment erupted. Black smoke poured from the barge. The engine stopped. The barge went dead in the water. The barge was 400 yards from shore, close enough that the crew might swim to safety. Too far for PT-48 to pursue without risking running aground. 3 barges engaged, 2 destroyed, 1 disabled. The fourth barge had escaped into darkness to the north. PT-48 had expended 3 magazines, 90 rounds, 0 American casualties. Lynch radioed Commander Calvert at Tulagi. The transmission was brief. The salvaged aircraft cannon worked. It worked better than anyone had expected. By 0300 hours, every PT boat commander in Squadron 3 was demanding an M4 cannon for his boat. The problem was Henderson Field only had 23 wrecked Airacobras. Squadron 3 had 12 operational PT boats. The mathematics did not work. By the 28th of October, 3 more PT boats had 37mm cannons mounted on their bows, PT-40, PT-46, and PT-60. Crews stripped 5 more wrecked Airacobras at Henderson Field. The salvage operation became systematic. Teams knew which bolts to remove first, which hydraulic lines to disconnect, which electrical connectors to cut. The second cannon removal took 90 minutes. The third took 70 minutes. By the fourth, they had it down to 55 minutes. The pedestal mounts improved with each installation. Frey refined the design after examining PT-48's mount following the first combat action. The rotating collar showed excessive wear. The bearing surfaces had scored from the gun's recoil forces. Frey added bronze bushings salvaged from damaged aircraft wheel assemblies. The bushings reduced friction. The second-generation mounts rotated smoothly under combat loading. Ammunition supply became the immediate bottleneck. Henderson Field's armory had horseshoe magazines for P-39 aircraft. Each magazine held 30 rounds, but the magazines were designed for aircraft combat. Aerial engagements lasted seconds. PT boat actions against barges could last 20 minutes or more. Mitchell had fired 90 rounds in PT-48's first engagement. The boat carried 6 magazines. 180 rounds total. Not enough. Aviation ordnance personnel at Henderson Field loaded magazines around the clock. Each magazine required hand, loading 30 rounds individually. The process took 8 minutes per magazine if the loader worked fast. The ammunition bay had 4 loaders working 12-hour shifts. They produced approximately 40 magazines per Dalton Y. The loading process was tedious and demanding. Each 37mm round weighed 1.61 pounds. The high explosive rounds had to be inspected before loading. Visual check for cracks in the brass casing, dents in the projectile, corrosion on the propellant charge. Any defect could cause a jam or misfire. The rounds were then inserted into the horseshoe magazine one at a time, oriented correctly, secured by the magazine spring, loaded retention system. The loaders worked in a Quonset hut 200 yards from the runway. Japanese air raids hit Henderson Field every 3 to 4 days. When the air raid siren sounded, the loaders had to secure the ammunition and take cover. Live 37mm rounds scattered across the floor during a bombing raid created obvious problems. The loaders developed a procedure. At the first siren, they would place all loose rounds back into their storage crates, close the magazines they were loading, and move everything into a sandbagged revetment outside the hut. This procedure cost time. Each air raid disrupted production for 90 minutes minimum, sometimes longer if the raid caused damage requiring repair work. The loaders were trying to produce 48 magazines per Dalton Y to support 4 PT boats running 2 patrols each. They were averaging 32 magazines per Dalton Y after accounting for air raid disruptions and equipment maintenance. 4 PT boats, each carrying 6 magazines, required 24 magazines per Pascal troll. The boats ran 2 patrols per night. 48 magazines consumed, 32 magazines produced. The deficit was 16 magazines per Dalton Y. The mathematics barely worked, and only because PT boats rarely expended all 6 magazines per Pascal troll. Henderson Field's ammunition stocks provided a buffer. The field had received 8,000 rounds of 37mm ammunition in September for the P-39 Airacobras. The aircraft were consuming approximately 200 rounds per Dalton Y in combat operations. The PT boats were now consuming 180 to 240 rounds per night. Combined consumption exceeded 400 rounds per Dalton Y. At that rate, the 8,000-round stockpile would last 20 days, Supply ships brought new ammunition every 2 weeks if weather and Japanese naval activity permitted. The 15th of October supply convoy delivered 4,000 rounds of 37mm ammunition. The 1st of November convoy delivered 6,000 rounds, but those deliveries were planned for P-39 aircraft consumption, not PT boat consumption. The ammunition allocation system had not adjusted to the new reality of salvaged cannons on boats. The high explosive rounds proved devastatingly effective against Daihatsu barges. The rounds were designed to destroy light aircraft structures, thin aluminum, magnesium components. The rounds worked even better against quarter-inch steel plate armor. Each round that penetrated created a 12-inch hole and sprayed shrapnel through the interior. 2 or 3 hits could disable a barge. 5 to 8 hits would sink it. PT-40 engaged 3 barges off Coley Point on the 27th of October. The boat's newly installed M4 cannon destroyed 2 barges in the first magazine. 30 rounds, 20 seconds of firing. Both barges burning and sinking within 2 minutes. The third barge escaped into darkness. Squadron 3 was learning that the 37mm cannon changed PT boat tactics fundamentally. Before the cannon, PT boats attempted to use torpedoes at long range, 800 to 1,000 yards. The torpedoes missed shallow, draft barges. The PT boats withdrew. With the cannon, PT boats could close to 400 yards and destroy barges with direct fire. The closer range increased danger from Japanese return fire, but it eliminated the problem of torpedoes passing underneath targets. Japanese commanders noticed the change immediately. Radio intercepts from the 28th of October indicated Japanese barge crews were reporting PT boats with heavy cannons and explosive shells. One intercepted message used the phrase, "demon boats with aircraft guns." The psychological impact was significant. Japanese barge crews had operated with relative impunity for weeks. Now they were being destroyed before they could deliver supplies. By the 1st of November 1942, 8 PT boats in Squadron 3 operated with salvaged 37mm cannons. Henderson Field had been stripped of every usable M4 cannon from wrecked P-39 aircraft. 21 cannons total had been removed. 17 were in service on PT boats. 4 were being held as spares for maintenance. The maintenance requirements were substantial. The M4 cannon was designed for aircraft service with extensive ground crew support between missions. PT boats operated for days at forward bases with minimal maintenance facilities. Saltwater corroded the hydraulic recoil systems. Tropical heat degraded rubber seals. Coral dust abraded the feed mechanisms. The saltwater problem was immediate and severe. PT boats operated in ocean environments. Spray from the bow wave covered the cannon during high-speed runs. The 37mm cannon had multiple external hydraulic lines connecting the recoil system to the barrel assembly. These lines used rubber seals at the connection points. Aircraft hydraulic systems used seals designed for dry environments at altitude. Ocean saltwater destroyed these seals within days. The first maintenance failure occurred on PT-40 on the 3rd of November. The boat was running a patrol off Savo Island when the cannon's recoil system failed. The hydraulic fluid leaked from a corroded seal. Without hydraulic damping, the cannon's recoil forces transmitted directly to the mount. The first shot after the failure cracked the pedestal mount's base plate. The crew secured the weapon and returned to Tulagi. Coogan examined the failed seal. The rubber had hardened and cracked from salt exposure. He searched Henderson Field's supply depot for replacement seals. The depot had aircraft hydraulic seals, but these were identical to the failed parts. He needed seals designed for marine environments. The solution came from an unexpected source. PT boats used hydraulic systems for their steering mechanisms. These systems operated reliably in saltwater environments because they used special synthetic rubber seals developed for marine applications. Coogan obtained samples of these seals from a PT boat undergoing engine maintenance. The seals were slightly different dimensions than the aircraft seals, but he could machine adapter fittings to make them work. He fabricated the adapters on the machine shop lathe. Brass fittings, custom dimensions, threaded connections. The adapters allowed the marine hydraulic seals to replace the aircraft seals on the M4 cannon. The modification took 4 hours per weapon. By mid-November, all PT boat cannons had been converted to marine seals. Gunners' mates learned to field, strip and maintain the weapons with improvised tools. Technical Sergeant Coogan transferred from Henderson Field to Tulagi in early November specifically to support PT boat cannon maintenance. He established a small workshop in a corrugated metal shed near the PT boat dock. The workshop had a workbench, a vise, basic hand tools, and a growing collection of spare parts salvaged from wrecked P-39s. Coogan maintained a logbook documenting every cannon serial number, every maintenance action, every failure mode. He was building institutional knowledge from scratch. Coogan trained PT boat gunners' mates on cannon disassembly, cleaning, and reassembly. The training took 3 days. Per man, day 1 covered the hydraulic recoil system, how to drain the fluid, inspect the seals, refill the system, bleed air from the lines. Day 2 covered the feed mechanism, how to disassemble the magazine well, clean the feed pawls, adjust the spring tension, reassemble without losing small parts. Day 3 covered the barrel assembly, how to remove the barrel, inspect for erosion, clean the chamber, reinstall with proper torque on the locking collar. By mid-November, every PT boat with a cannon had at least one crew member who could maintain it. Some boats had 2 trained men. The distributed maintenance capability meant PT boats could operate from forward bases without returning to Tulagi for every minor malfunction. The success of the field modification reached higher commands quickly. Commander Motor Torpedo Boat Squadrons, South Pacific reviewed. After-action reports from Squadron 3-8 patrols, 23 Japanese barges engaged, 14 barges destroyed, 6 barges damaged, 3 barges escaped. 0 PT boats lost in those actions. The 37mm cannon proved itself statistically. On the 18th of November, Commander Motor Torpedo Boat Squadrons, South Pacific sent a dispatch to Bureau of Ordnance in Washington. The dispatch was classified confidential. It detailed the field modification, described the combat results, requested official approval for the installation and formal procurement of M4 cannons for PT boat use. The request included technical drawings of the pedestal mount design, ammunition consumption data, maintenance requirements, everything needed for institutional adoption. Bureau of Ordnance received the dispatch on the 23rd of November. The bureaucratic process that followed would normally take months. Design review, safety analysis, procurement planning, production scheduling. But the combat results from Guadalcanal were undeniable. PT boats with 37mm cannons were destroying Japanese barges at unprecedented rates. The field modification worked. On the 7th of December, 1942, exactly 1 year after Pearl Harbor, Bureau of Ordnance authorized production of standardized pedestal mounts for M4 cannons on PT boats. The mount would be manufactured by a contractor in Rhode Island. Initial production run, 100 units. Delivery timeline, 90 days. But PT boats in the South Pacific needed the cannons now, not in 90 days. Motor Torpedo Boat Squadron, 6 arrived at Tulagi in mid-December 1942. 12 boats, fresh crews, standard armament. Twin .5, O-caliber turrets and 20mm Oerlikon cannons. Number 37mm aircraft guns. The squadron had deployed from the East Coast expecting to fight with torpedoes. Instead, they found Squadron 3 destroying barges with salvaged cannons. Squadron 6's commanding officer requested immediate cannon installation for his boats. The problem remained unchanged. Henderson Field had no more wrecked P-39 aircraft to salvage. The solution came from an unexpected source. The Army Air Force was receiving new P-39 variants, the P-39N and P-39Q models. These aircraft had the same M4 cannon. Some aircraft were being retired from service due to combat damage or mechanical failure. The aircraft were being stripped for parts before disposal. Coogan negotiated with the Army Air Force Supply Depot at Henderson. The depot had 6 P-39 aircraft awaiting disposal. The cannons were still serviceable. The Army agreed to release the weapons to the Navy for PT boat use. By January 1943, 14 PT boats in the South Pacific operated with 37mm cannons. The weapon had spread from Squadron 3 to Squadron 6. Combat results continued to validate the modification. January patrol reports documented systematic destruction of Japanese barge traffic. 37 PT boat patrols engaged Japanese barges, 41 barges destroyed, 19 barges damaged, 8 barges escaped. The 37mm cannon gave PT boats offensive capability they never had with torpedoes alone. More importantly, PT boat losses decreased. September through November, Squadron 3 lost 6 boats. December through February, with cannons installed, 2 boats lost. Neither loss was attributed to barge engagements. The tactical doctrine evolved rapidly. PT boats learned to attack barges in pairs. One boat would close to 400 yards and engage with the 37mm cannon. The second boat would provide suppressive fire with .50 caliber machine guns and stand by for torpedo shots if larger vessels appeared. Lieutenant Robert Lynch survived the war. He commanded PT-48 through the entire Solomons campaign. 15 months of combat operations, 47 patrols, 19 confirmed kills. He received the Navy Cross for actions in November 1942. The citation specifically mentioned the innovation of mounting aircraft cannons on PT boats. Chief Machinist's mate, Donald Frey, designed the original pedestal mount in Henderson Field's machine shop. His crude design became the basis for factory production mounts, manufactured 18 months later. Frey received a commendation for technical innovation. He never received a patent. The design was government property. Technical Sergeant James Coogan spent the remainder of the war maintaining PT boat cannons. He trained over 200 gunners' mates on M4 and M9 maintenance procedures. After the war, Coogan remained in the Air Force. He retired as a master sergeant in 1962. The M4 cannon salvaged from wrecked Airacobras at Henderson Field changed naval warfare in the Pacific. The weapon gave small, fast boats the firepower to destroy armored vessels. The innovation was born from desperation, fabricated from junkyard parts, and validated in combat. By war's end, 531 PT boats had served. Nearly all carried 37mm cannons. The weapon that began as field improvisation had become standard naval armament. 800 Japanese vessels destroyed. Most were barges. Daihatsu class barges carried 60 troops or 8 tons of supplies. 800 barges destroyed meant 48,000 troops that never reached their destinations, or 64,000 tons of ammunition and food that never arrived. Japanese commanders acknowledged PT boat effectiveness in post-war interviews. Vice Admiral Takeo Kurita commanded naval forces in the Philippines. His staff kept records of supply losses. November 1944 through January 1945, Japanese forces in Leyte lost 73% of barge convoys to PT boat attacks. The losses forced a complete restructuring of Japanese supply operations. In September 1944, Japanese forces in Leyte received 85% of scheduled supplies via barge convoys. By December 1944, that figure had dropped to 22%. The remaining supplies arrived via submarine, aircraft drop, or did not arrive at all. Japanese naval commanders attempted to counter PT boat cannon effectiveness through tactical adaptation. They increased destroyer escorts for barge convoys. The destroyers would engage PT boats at long range with 5-inch guns while the barges scattered. This tactic reduced barge losses, but consumed destroyer resources needed elsewhere. Each destroyer assigned to barge escort duty was a destroyer unavailable for fleet operations. They experimented with armored barges. The Type 103 landing craft introduced in late 1944 had half-inch steel plate armor instead of quarter-inch. The increased armor was designed to resist 37 mm cannon fire. In practice, the armor stopped some rounds, but the weight penalty reduced the barge's speed and cargo capacity. A Type 103 could carry only 40 troops compared to 60 on a standard Daihatsu. The slower speed made the barges easier targets. PT boats simply fired more rounds to achieve the same destructive effect. They attempted night operations using total blackout procedures. Barges would run without navigation lights, relying on coastal landmarks for navigation. This reduced detection range but increased accidents. Barges collided with each other, ran aground on reefs, or missed their landing points entirely. The tactical adjustment created new problems, while only marginally reducing PT boat attack effectiveness. The strategic impact extended beyond simple mathematics of destroyed barges and lost troops. Japanese ground forces across the Pacific began experiencing systematic supply shortages. Ammunition rationing became standard. Food supplies dropped below subsistence levels. Medical supplies ran critically low. These shortages degraded combat effectiveness more than direct battle casualties. On Leyte, Japanese forces defending against American invasion consumed ammunition at rates far exceeding supply delivery. Artillery units were ordered to limit fire missions to critical targets only. Infantry units were restricted to rifle fire, except in emergencies. The supply constraints imposed by PT boat interdiction created tactical restrictions that advantaged American ground forces. The Junkyard cannon they mocked became the weapon that starved an army, not through dramatic fleet engagements or massive battles, but through systematic destruction of small vessels carrying food, ammunition, and reinforcements. 800 barges destroyed meant 48,000 troops that never reached their destinations, or 64,000 tons of supplies that burned in wreckage, floating in the slot. The innovation succeeded because it solved a specific tactical problem with available resources. PT boats needed a weapon effective against armored barges. Henderson Field had cannons sitting in wrecked aircraft. Chief Frey had the skills to mount them. Lieutenant Lynch had the determination to test them in combat. The weapon worked because it addressed an actual need with practical engineering. By war's end, the field modification had become standard doctrine. New PT boats were manufactured with 37 mm cannon mounts integrated into their design. The Bureau of Ordnance developed the M9 cannon specifically for naval use. But those factory solutions came 18 months after Lynch Frey and Coogan improvised the first mount in October 1942. The men who salvaged cannons from aircraft graveyards and bolted them to plywood decks never received recognition beyond their units. Frey got a commendation. Coogan got a transfer. Lynch got a Navy Cross for multiple actions. The cannon innovation mentioned briefly in a longer citation. The weapon they created destroyed more enemy vessels than any other PT boat armament system in the Pacific War. Not because it was sophisticated, not because it was approved by higher command, not because it followed doctrine, because it worked. The Junkyard cannon they mocked became the weapon that starved an army.